Hello, my name is Nikolai and this is my presentation. First of all, I wanted to talk about bad coding practices. First one is about not using constants and hard coding. It causes that values are not centralized and every change can break everything in another place, and the new developer has unknown magic values in parts of the code. He has no idea what is going on here. Next one is not writing self-documented code, and the developer is wasting a lot of time on trying to find out what's going on here instead of just taking a look and doing things. Next one is reinventing bicycles. I can say that it's definitely a bad idea to implement everything yourself and just not checking if anybody had similar problem and he implemented that and he has code shared somewhere and all that stuff. And next one is being closed for new technologies. It's also a bad idea because a good developer should be up to date with new technologies, because new technologies can solve your problem much faster or much easier. So yeah, you need to be up to date. And the last one is lack of testing, because yeah, nobody loves to write tests, but people underestimate the importance of them, and some new functionality can break everything. You have a lot of time wasted on manual testing, and we even cannot talk about CI. But now let's talk about CI and CD. So in ideal world, we have coding stage, then we are doing a pull request, somebody checking our code and he is, for example, accepting our pull request. We are going to static analysis, we go into unit tests, and then deploy to staging environment. And here we have some integration test, load test, acceptance test, maybe Selenium end-to-end test or something like that, and then we are deploying to prod. And here we just taking a look if things are going well. So for some generic project, we can have some generic tools. Then we are choosing them based on popularity, because popularity means that we have a good community that can help us, and also we have good integrations with other tools. So I took Jenkins because Jenkins is quite popular. I have a lot of experience, and I think it's popular among developers, and it's suitable for really different cases, and for generic project it is enough to have Jenkins. Also, GitHub is okay. It has everything we need to make pull requests, to make version control. Maybe we can use Source Tree to make things maybe more handy, and also some artifact management repository, Nexus, for example. It's also free Nexus is enough, and it's very simple to config, just few clicks, and so it's also very handy. Next, we are going to understand what is hard problem. So mostly a hard problem for me is when I don't know how to solve it. For the first time I see it, because mostly when I see problem, I have some idea how to solve it. So it can be caused by lack of experience or lack of skills, or maybe untraceable, non-repeatable bugs, but it's not about that. So for example, I had a problem when there was a new project for me. We had some integration with medical systems about, I'm talking about HL7 DICOM protocols, and the whole team was absent, and we have some problems with DICOM, and I have no ability to debug that because we have box installations in hospitals, and the access was very limited for us. And new release should be in just 2 weeks, for example. So I needed to do a lot of things simultaneously. I just planned a workshop with all developers. I contacted library developer to exclude maybe some known issues, and also I found some short description of DICOM protocol to find out the main idea of how it's working. Then I validated my thoughts with all team. Then during that my team was covering that code with tests and excluding parts one by one. So in the end, I planned 2 debug sessions with Gospital DevOps, and first one for getting some helpful logs maybe, or something helpful, some helpful ideas, and second one to validate if my solution is okay and no more errors are happening. So yeah, I fixed the problem was with pre-processing some videos and having some custom handlers, but it's details. So in the end, I got some soft skills, maybe how to organize people resource for problem solving in short time, and how to use the experience for my case. Also, yeah, I had an example how not writing tests is causing big problems, and also my team also understood that, and also there was some example how to debug project in that kind of environment when you have no access and you are just doing some debug sessions from both sides. And yeah, for that project I understood how to handle DICOM and how to handle videos. It was good, but maybe it will not very helpful in other projects because there are not a lot of medical ones. So what about NoSQL and SQL? I have three SQL examples from my real life, and first one is backend banking web service, and we need to have consistent transactional environment that need to have ACID there, so it is SQL case. Next one is government document exchange system, and here we have schema, and the law is already defined and stable. It's regulated by government documentation, and we have some complicated requests, and yes, it means that SQL is good for that. And third one is quite similar. We have some complex company with a lot of entities and some business process that is very complex but established enough, and also we have some complicated requests and reports, so it's a good case for SQL. And for NoSQL we have three examples. First one is social startup backend. I can talk about that because it's something growing. Schema is changing. It's not so complex. We need to have something easy to scale because user count is growing. We don't need consistency. We need just eventual consistency. So it's a good case for NoSQL. Next one is something about CMS that needs customization for each user, but it's some e-commerce SaaS, and a lot of shops can be connected, so we need easy scalability, but schema is not so complex, so it's good, also good case for NoSQL. Last one is some crash stats and analysis for mobile app. It's big data system, so we don't need some we don't need consistency, we just need scalability. We have plain data that is denormalized, and we need some flexible model, so it's also a very good case for NoSQL. And the last one is techniques for high quality and highly maintainable code. First one is dry, don't repeat yourself. It causes that we have no duplicates, we have changing things centralized, we have no different versions in different places of code, and no bicycles and all this stuff. Next one is keys, keep it short and simple. So it's about splitting tasks and splitting code into small pieces, and it's good because we have easy estimations, easy to control things. The code is not over-engineered and over-designed. The methods are small and easy to understand, and you are just solving issues, not staying in one place, as it happens sometimes. Next one is solid. It's good pack of old object-oriented design principles. They are easy to use, and system appears to be easy to use and easy to change and easy to extend, and also easy for comprehension, for understanding. Next one is about testing, and about testing from the beginning, because the later you start, the more time you waste, and the whole team should be involved into the testing. And other tests can save you a lot of time. Just take some time in the beginning, but save a lot of time later. Code is not breaking. You are not wasting time for fixing some bugs that you already fixed. You know, all that stuff. And the last one is self-documentation and documentation everything that was not self-documented. And it's really important because sometimes a lot of time spent for developer to get into new project, but when he's fixing bugs and he sees self-documented code, he can do it easily. And code can be interpreted wrong by developer and can lead to logical errors and time bombs. And so in the end, for me, it means that I will use constants with clear names, use variables, class, and method names. Describing behavior, I will write comments for some strong algorithmic parts, and keep everything documented, all architecture, design, and up to date. I'd make everybody in my team to follow coding rules and documenting guides. And also, we can write tests that can explain logic. So that's it. Thank you. Goodbye.